Hi everybody, my name is Gu Weiwen, matrix number 154693. This is the length of the copper wire reading of our group. The first reading is 0.9975 meters. The second reading is 0.9985 meters. The third is 0.9970 meters. The fourth is 0.9950 meters. Same with the fifth one. The sixth is 0.9965 meters. The seventh reading is 0.9975 meters. While the last one is 0.9970 meters. The sum of the eight reading we taken is 7.9740 meters. And I use the formula V2 to V9 to calculate. And the average value of the length of the spool wire is 0.9975 meters. And I use this formula average V2 to V9 to calculate. So that this column is the value of V2 minus this average value, and we get the 0.00075 meters per first pass. This is the S1. And the sum of this column value is 0.0. The third column is the this value. So we can see that I use the formula C2 times C2 to get this column of value, and the sum of column of value is 0.0000105 square. And the variance of the length of the copper wire is 0.000015 meters. I use the formula D10. The sum of this column value divided by the 7. 7 is the number of reading minus 1. And so that the seventh division of the length of the copper wire is 0.0012244745 meters. I use this. It comes from the period of variance, so we can see that the formula is D12 power of 0.5, and the standard error of our length of copper wire is 0.000433013. This formula is come from the D13 here over total number of reading we taken, that is x power of 0.5. Okay, thank you.
Okay, I'm Isha Safidaran. I would like to explain about the reading that we get for the resistance of the copper wire. First, we have the reading, which is the first one is 0.5, second one is 0.6, third one is 0.5, fourth one is 0.6, fifth one is 0.4, sixth one is 0.6, seventh is 0.5, and number 8 is 0.52. 0.5. So in order to get our average resistance, we sum up all the readings from here, which is 0.2 0.2 ohm, and In order to get the average resistance, the sum of this reading is divided by the number of measurements, which is 8, and the answer is 0.52 ohm. So for the second column, the reading is the subtraction of these measurements by the average, and the third column is the square of these measurements. For the variance, in order to get the variance, we calculate the sum of the square of these values and divided by the total measurements minus 1, and the answer is 0.005 ohm square. That one is the standard deviation. The standard deviation is the square root of the variance, which is 0.07071 ohm. The last one is the standard error. Standard error is the formula where it's the standard deviation divided by the square root of the number of measurements, which is 8, and the answer is 0.025 ohm. That's all. Thank you.
Okay. All right. Hello. My name is Ifai. I'm going to share about our reading of the diameter of the copper wire. Um, the zero error we get here is negative 0.005 millimeter. Okay. So for the first reading, we get 0.00019 meter. The second reading, we get 0.00019. The third reading, 0.0000193. The fourth reading, 0.0000195. The fifth, 0.0000187. The sixth reading, 0.00019. 7, 0.0000182. The last reading, 0.0000193. Okay, and then here we calculate the sum, and then the mean we calculate the average here. After we calculate the mean, we then calculate the difference between the reading we get here with the mean. For the first and the second reading, 0 because we get the same. And then the third, we got 3 multiply 3e to the power negative of 6. And then for the fourth, we get 5e to the power of negative 6. And then for the fifth, we get negative 3 e to the power of negative 6. And then the sixth reading we get 0. And then for the seventh reading we get negative 0.00008. Same, negative 8 to e to the power of negative 6. And then last, we get 3 e to the power of negative 6. After we calculate the variance, we power it and then for the first we get 0, second same, the third we get 9 e to the power of negative 12. For the fourth reading we get 2.5 e to the power of 11. For the fifth reading we get 9 e to the power of negative 12. For the sixth we get 0. For the seventh reading we get 6.4 e to the power of negative 11. And last, we get the 9 e to the power of negative 12. So we calculate the sum. Then after we calculate the sum, we calculate the variance, which is the formula is I don't put it here, but the formula is the sum of the power of the variance divide by the number of measurement minus by 1. Okay, so we get here so 1.65714 e to the power of 11. Then after we get the variance, we can get the standard deviation. We just square root the variance, and then finally we calculate the standard error, which the standard deviation here we divide it by with the square root of the value here. Okay, so that's all for me.